Today we will talk about the sequence. Okay, sequence, if we have like numbers 3, 8, 13, 18, and so on. This is the first term in the sequence, and this is arithmetic sequence. We could understand this by subtracting the first term from the second, which is a2 minus a1, 8 minus a3, which is 5. Then you have also to check, for example, a3 minus a2, okay, which is equals to 5. So this is the first term, second term, third term. And then you have also to check a4 minus a3, which is again the same. So they are all giving the same difference, and this is what we call arithmetic sequence. Okay, you may sometimes they ask you to find the next two terms or three terms. Then what you are going to have is just, okay, you need every time to add 5, add 5, add 5. So if you add 5 here, you get 23. Then you add 5, you get 28, and so on. So this is the okay, the next two terms. Okay, what we wish now to find is what we call the nth term, the nth term here. Okay, that's what we are going to find. So the first term, as you can see, if we call it a, then we are adding to that a5, which is the difference, so we're adding the difference here. Then we add again the difference, so we'll get 2 from that difference. Then we add again one more difference, so we get 3 from the difference, and so on. Now if you take a look, the second term is a plus 1d, okay, 1 here. And the third term, if you take a look, is a plus 2d. And the next term is, okay, the fourth term is a plus 3d. So you may think also that the fifth term should go to a plus 4d. That is 5 minus 1. And the 10th term, for example, is a plus 9d. Okay, that's 1 here. 10 minus 1, which is 9 here. Okay, so if you are having also, let's say 100, you want to get the 100 term, that's a plus 100 minus 1, which is 99, then d. So the nth term is just an equals to the first term plus n minus 1 times d. You need to memorize this formula, okay, or understand it. Okay, here is a question. Find the 25th term, okay, of the arithmetic sequence whose first term is here, negative 12. This is the first term. Then you need to get the difference, so that's minus 6 minus 12. So minus 6 minus 12, that is negative 6, plus 12, which is just 6. Now if you add here 6, you get negative 6. If you add 6, you get 0, and so on. What we need the 25th term. So we know the formula, which is a plus n minus 1 times d, right? And 25 here, and we have the first term, which we call a, which is minus 12. And 25 is 25 minus 1, which is 24. And the difference is 6. What you need is just simply multiply 6 times 24, then subtract the 12, and you will get the answer. Okay. Here another question. The 15th term of arithmetic sequence is negative 3. So a15 equals to negative 3. Then we are also having the first term is 25. So the first term equals to 25. So find the 10th term. Okay. We need actually the difference to find the 10th term. We know that an equals to a plus n minus 1 times d, right? And if we use n equals to 15 here, then this is a15, which is equals to negative 3. We could write the value for this, and equals to a, and a is 25. If I use n equals to 15, then this is 15 minus 1, which is 14, times d. Again, it is just negative 3 equals to 25 plus 14d. Okay, now if I move this to the other side, I'll get negative 28 equals to 14D. And from here, I'll get D, just divide by 14, divide by 14. Here you get negative 2. Okay, now back to our question. We need to find the 10th term. So A10 equals to A plus 9D. Okay, and A is 25 plus 9 times D, which is negative 2. That is 25 minus 18, which is equals to 7. Okay. Okay, the next thing what we are trying to do here is we are trying to find the sum of arithmetic sequence. We need to add all of them. So in the sequence we have the first term is A, then I add D, so I get A plus D, then A plus 2D, until I reach the last term here, which is L. If I don't return back from the last term to the one previous, so I need to subtract D. Then I subtract another D, so that's the last term minus 2D. Okay, what is series here, at least at this moment, it's just you need to add all terms together. So this is A, the first term, plus the second term, plus the third term, plus till the last term here. Okay, you need to find a formula for the sum, and that sum we will call it Sn. Okay, and how could I find this? Okay, let me just arrange them. I'll take A here, A plus D here, A plus 2D here, plus, and I'll start now from the last here, which is L. Then L minus D is here. Okay, then L minus 2D is here. If I add, I'll add A plus L, so I'll get A plus L here. Okay, if I add these two terms together, I'll get also minus D cancel with minus D, I'll get A plus L. And here also 2D minus 2D, they cancel with each other. And 3D and minus 3D also, they cancel each other. So I'll get A plus L. The sequence here was having nth term, okay? Having nth term. So I'm having here n over 2 terms because I divided in 2. So it is just n over 2, and that is multiplied by this number, which is A plus L. We know A is the first term, and L is the last term. Okay, we are having also another formula for the sum of the nth terms of arithmetic series. Okay, this is the formula we derived. Now we will just replace L by this quantity, because we know that An equals to A plus n minus 1 times D. And if I use, this is the L, the last one, so this is A plus n minus 1 times D. This is the last one. Okay, now I'll just take that L and put its value here. And I find that's, I'm having n over 2, which is the same as here, and A plus A, which is 2A, plus n minus 1D. So we are having two formulas for the sum, and both are same. Okay, sometimes we prefer to use this, sometimes we'll prefer to use the first one. It depends on the question, and you have also again to memorize this formula. Okay, find the sum of the first 50 terms. So we need to add 50 terms of this sequence, right? And we know from here A equals to 1, and the difference is 3 minus 1, which is 2, and here the difference is 2, and the difference here is 2, so the difference is 2, and here is same. Okay, so we need to find the sum of 50. So I'm going to use S50. Now I don't have the last term, so I prefer to use this formula. Okay, so that's 50 over 2. 2 times A is 1, so that's 2 times 1, which is 2, and n minus 1, which is the term 50 here, 50 minus 1, which is 49, times D, which is 2. Okay, now that is just 50 over 2, and 2 plus, this is 98. Okay, and that's 100. If you take a look, that's 100. So 100 over 2 is just 50. So that's 50 times 50. You can write it 50 square, or just put 2 zeros and 5 times 5, 2,500. Okay, here is another question. An arithmetic sequence has 3 as its first term, so a equals to 3. Okay. Also, the sum of the first 8 terms, the sum of the 8 terms is twice the sum of the first 5 terms. So the sum is 8. That's the sum for the 8 terms. Equal twice. Twice means 2 times the sum of the first 5 terms. Okay, that's the equation I got. Okay, right? And now S8 is equals to, we know the formula, which is n over 2a plus n minus 1 times d, right? This is the sum. This is Sn. Now S8 will be 8 over 2, which is 4, okay, and 2 times a, which is just 6, and n minus 1, which is 7d, because we don't have the difference, right? And here is 5 equals to, okay, so that's 5, here is 5, so here 5 over 2, okay, then 2 times a, a again is 3, so that's 6, and n minus 1, but 5, n is 5 here, so that's 4 times d, okay. Now S8 from this equation, S8, which is, okay, I can multiply here if I wish, which is 24 plus 4 times 7, 28d equals to 2 times S5. So S5 multiplied by 2, so that's 2. If I multiply here 2, multiply here 2, I'll cancel these 2, so I'll get 5 times 6, which is 30, and 5 times 4, which is 20d. Okay, now I can take this is to here, so I'll get 28 minus 20, that's 8d, and here is 24, here is 30 minus 40, which is 6, so my d here is 6 over 8. If I simplify it, but dividing by 2, I'll get 3 over 4, that's the d. Okay, so the question was find the common difference, and we found the common difference. Now you have the first term is a 3. You can just add 3 plus 3 over 4 and continue this way to generate whole sequence. This is actually involve sigma for the sum, but maybe I'll do it next time, not this time. We need maybe some introduction for sigma. Okay. Here is just note, we need to add numbers like 1 plus 1. We need to add 1 plus 2, sorry, plus 3 plus 4 plus so on. Okay, now this is like the difference is 1, and we have n, so this is n over 2, and the formula was, if you remember, a or 2a, which is 2 times 1, which is 2, plus n minus 1 because we don't know n, and the d, the difference is 2 minus 1, which is just 1. Okay, and if I try to simplify this, I'll get n over 2, okay, and that's n here, and this is 2 minus 1, that's plus 1 over 2, so that's n times n plus 1 over 2. What does this mean? If you are going to add 1 plus 2 plus 3 plus, let's say 100, then that is very easy to find. You just plug it here, you get 100 times 100 plus 1 over 2, which is, that's just 50. 50 times 101. You need to multiply this. This is the sum for the first 100 integers. Okay. Here is what we are having is the arithmetic mean. Arithmetic mean means you are given two numbers, a and b. You need to insert the mean between them, which is the mean is just add them and divide by 2. So this is a plus b over 2 plus b. And b. You can look at this now as a sequence, as arithmetic sequence, okay? And the difference between this and this is just the difference is same as here, okay? You can check this. Now, usually you will be asked in exams to insert k numbers or k arithmetic means. So you can form just a sequence, which is a, then this is the means here between them, the k, and this is b. Now this sequence, actually the first term you know, which is a, and the last term you know, which is b, and you know the number of the term, this is k terms, plus 1 plus 1, so this is k plus 2 terms. Okay, and here is what we are having. Okay, we need to insert the 3 arithmetic means, so that's 3, C1, C2, C3, those are the arithmetic means. So we have an arithmetic sequence and we have 5 terms, so A equals to 3, and okay, A1, A2, A3, A4, A5, that's A5 equal to 13. And we have AN, as you remember, equals to A plus N minus 1 times D. If I use A5 here, N equals to 5, so that's the answer is 13, and A equals to 3, and we know that N equals to 5, so 5 minus 1, which is 4, and times D here, right? And from here, I could say, okay, that I can take 13 to the other side, 3 to the other side, I get 10 equals to 4D. Now my D equals to 10 over 4, which is just, if you divide by 2, you get 5 over 2. Now, what is this numbers? Okay, so you start from this as arithmetic sequence. So this will be 3 plus 5 over 2, and the next one is 3, 5 over 2 plus 5 over 2, and the next one is 3 plus 5 over 2 plus 5 over 2 plus 5 over 2, and the last one is the 13. You can check now. You need just to work on these additions. So that's a 3. Okay, this is, you can multiply it by 2 over 2, and that will be 6 plus 5, which is 11 over 2. And this is actually 10 over 2, which is 5. 5 and 3, which is, I guess, 8. Okay, and this is, you know, this is 10 over 2, which is again just 10 over 2, which is again just 5. So that's 8 plus 5 over 2, and this is 13. We need to work on this. Multiply by 2 over 2, you get 16 plus 5 over 2, which is 21 over 2. So that's just replaced by 21 over 2. Now this is the arithmetic means here, the 3 arithmetic means. Okay, well, this could be the last idea. What we are having is arithmetic, but it's actually generated by quadratic formula, degree equals to 2. Here, for example, let's try to find the first 6 terms. So if we are going to substitute with n equals 1, okay, so this y equals 1. Here is 1 square plus 1. 1 square is 1 plus 1 minus 1, and that's the answer is 1. 1 minus 1, 0, you get 1. And the second one is, if you substitute 2, you get here 4. 2 square is 4. And this is the 2 here minus 1. So that's 6 minus 1, which is 5. Then you are going for U3, for example. Okay? And this will be 9. And n equals to 3. So that's 3 minus 1, which is 2. So that is just 11. Okay? Then you are going for U4, for example. So this is 16 plus 4. That's 20 minus 1, which is 19. Okay, let me stop at U5 maybe. Okay, so that's 25 plus 5, that's the 30 minus 1. 30 minus 1 is 29. Now let me just write them, all of them together. This is 1, then 5, then 11, then 19, then 29. Let me compute the difference. The difference is 4. The difference is 11 minus 5, which is 6. The difference is I guess 8. The difference is 10. So this is not like, does not look like arithmetic. This is the first difference. And since it's a quadratic, it's going to be working with the second difference, not the first difference. What I mean by this is, you take this difference and say this is 2, this difference again 2, this difference is again 2. Okay, so we need to look at the second difference sometimes in arithmetic with the quadratic formula. Okay, here is a question. It's given for me, or it's asked me to find the formula for the quadratic sequence. Okay, and what I'm having is 2, 9, 20, and so on. I work on the first difference, which is 9 minus 2, 7. Here is 11. Here is 35. Here is 19, and so on. I don't see any difference. I don't see the difference, right, for arithmetic. Now, if I take 11 minus 7, I guess this is 4, and here again this is 4, and here is 4. So we have a second difference. Okay, we need to find the general formula. We know this is a quadratic sequence, so there is a number with n squared, there is a number with n, and there is a number with c. And our job is to find this a, this b, and this c, similar to what was given to me here, right? And you see here the a was 1, the b was 1, and the c was -1. So if we know these numbers, okay, we can find the general formula. How can we find this? This is not that tricky. Okay, let's go for the first term. The first term is, okay, with n equals 1. So if you substitute 1, you get 1 squared, 1. So that is just a, and here is b, and here is c. If you substitute n equals to 2, you get here 4, so that's 4a. If you substitute 2, you get 2b plus c. If you substitute 3, you get 9a. If you substitute 3, you get 3b, okay, plus c. If you substitute 4, you get 16a, and that is 4b, and because n equals to 4 plus c. Okay, now you work on the first difference here. Okay, if you work, I should not put this line, but I'll say this here. Okay, so 4a minus a, that's 3a. Okay, and 2b minus b, it is just 1b. Okay, and c minus c, which is 0. So this is the first differences here. Okay, the second difference you can work also here. This is the first difference, sorry. 9a minus 4a, which is 5a. Okay, 3b minus 2b, which is just b, and c minus c, which is 0. Okay, you can work also the difference here and write your answer there. Now this is the first difference. We need to go for the second difference, so the difference between these two guys. Okay, so 5a minus 3a, which is 2a, and b minus b, which is 0. Look again, this is the 2a here, which is the second difference, which is this number here, right? Okay, so that's the second difference. So 2a here equals 4. Okay, I hope so you can see it here, right? From this, so a equal, you divide by 2, you get a equals to 2. Now we solve for this. We can return back for here because we know a, and we need just to find b, and this is just the first difference here. So this is this number here, right? Okay, so that's here, and this is the first difference here, and that number is 3a plus b. So 3a plus b equals to 7, and we know a is 2, so that's 6. And move it to other side, you get b equals 1. Okay, now I guess you know how to find c. Okay, you see here we moved from here, then up to this, then up to here, because we know a and b. We can look at c, which is the first number here. You see we moved from there to this, then to this number. So we could say a plus b plus c equals 2. Here you could see that's equals to 2. Okay, and b equals 1, a equals to 2. Okay, so c, if you solve for c, okay, that's 3. Move it to other side, you get c equal to -3. Now the general formula, okay, you have an equals to a n squared plus bn plus c. You just substitute for a, you find it 2, so this is 2n squared, and you find b equals 1, so that is just n. Okay, that's 1 times n, which is n, and you find c equals to -3, and that's -3. Okay, so this is just for the arithmetic, and we need to work on the geometric sequence next time. Then we will go also for the sigma notation and how can we deal with it. Okay, I'll send you the whole questions and file with the questions. You need to solve them.